Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at differentiation, specifically the second derivatives in order to determine the stationary points. This is part 8. Make sure to subscribe and check out our previous videos. We also have a variety of playlists, including integration, polynomials, quadratics, among others. But this one is for differentiation. Recall, from part 5 of differentiation, where we introduced the second derivatives, we are going to build up from that. So in this session, we cover the determination of the nature of stationary points, making use of the second derivative. So as you would recall, from part 7, we looked at method 1, where we looked at the sign change method. But today, we were looking at the second derivative method. So when it comes to the types of turning or stationary points, we have the maximum point, and as you may recall, if we have the curve y is equal to f of x, then we have the first derivative, or dy dx, being equal to 0, and the second derivative being less than 0, then it means we have a maximum point at that particular point. So take note, for a maximum point, the second derivative has to be less than 0, and at the same time, the first derivative must be equal to 0. Secondly, we have the minimum point. So for the minimum point, we have the first derivative being equal to 0, as usual. However, the second derivative is greater than 0. So take note, if the first derivative is 0 and the second derivative is greater than 0, meaning positive, it implies that we have a minimum point. So I hope that makes sense and that's not confusing at all. I know it might appear confusing. For a maximum, we get the negative for the second derivative, and for the minimum, we get the positive in the second derivative. But that is something that we just have to appreciate for now. Let's take a look at example 1. Find the coordinates of the stationary points on the curve y is equal to x to the power 4 plus 4x minus 1 and determine the nature of the points. These are the stationary points. So the solution, we first find the first derivative, dy dx, which is 4x cubed plus 4 is equal to 0. We equate this to 0 because we know that if this has stationary points, we must have the first derivative being equal to 0, which was the first conditions that we looked at on the left-hand side. Now, after equating to 0, we go on to solve for x. So in this case, we have 4x cubed is equal to minus 4 because we shifted the 4 to the other side. Now with that, dividing both sides by 4 and finding the cube root of everything on the left-hand side and the right-hand side, we get the x being equal to minus 1. Now, we have the value of x of minus 1. We now want to find the corresponding y value. So we substitute for x into y. Then we are going to get y of minus 1 being all of that. Where we had x, we substitute with a minus 1. We simplify further so that we get a minus 4. So the turning point is minus 1 minus 4. That is the turning point. Now we move on to determine the nature of the turning point. Now we consider the second derivative. So as you would recall, the second derivative is differentiating the first derivative once again. So in doing so, we are going to get y prime prime of x, which is equal to 12x squared. Now that we have the second derivative, what's left is to evaluate at the turning point using the x coordinate, and our x coordinate was a -1. So in short, we are trying to find the y prime prime of -1. So where we had x, we substitute with a -1. So that we have 12 times -1 squared. Now that would give us a positive 12. And we know that a positive 12 is greater than 0, or in simple terms, that is positive. So if the second derivative is positive, whereas the first derivative is 0, that implies that the turning point -1, -4 is a minimum point. Question answered. Let's take a look at example 2. A curve has equation y is equals to 2x cubed minus 3x squared minus 36x plus k. A. Find the coordinates of the two stationary points, and B. Hence find the two values of k for which the curve has a stationary point on the x-axis. The solution. As we are given the y, we can move on to find the dy dx, which is the first derivative of 6x squared minus 6x minus 36. And we equate that to 0 because we want to find the stationary point. So we always equate this to 0 for the stationary point. Now with that, we want to solve for x. But before we do that, we can actually simplify our work by dividing throughout by 6 so that we have x squared minus x minus 6 is equal to 0. Now, from the quadratic factorization video, we have a playlist on quadratics. Make sure to check it out so that you benefit a lot from it. We know that we can use the factorization method to solve this particular equation. In so doing, we have x squared minus 3x plus 2x minus 6 is equal to 0. And of course, factoring out the common terms in the first two pair and the last the first pair and the last pair of terms, we are going to get x minus 3 times x plus 2 is equals to 0. And with that, we know that we can separate the terms so that we have x minus 3 is equal to 0 or x plus 2 is equal to 0. And solving for x, we are going to get two values of x. One is minus 2 and the other one is a positive 3. For the stationary points on the x-axis, we know that on the x-axis, y is equals to 0. With that, we are going to substitute for the x value of minus 2 first. So now, when we substitute into y, wherever we had x, we substitute with the minus 2 and we equate that to 0 because this is the x-axis. And the x-axis happens when y is equals to 0. So we equate the y to 0. With that, we move on to simplify and solve for k. So the value of k that we get when x is minus 2 is a minus 44. So that will be the value of k at which the stationary point is on the x-axis for the first one. Now for the second one, we know that we obtained the x value of 3. Substituting that x value into the y, we are going to get that expression and equating it to 0 because this is on the x-axis. On the x-axis, y is equals to 0. Now with that, we solve for k so that we get k is equals to 81. So this is how we answer question 2. Let's take a look at the final example for the day. Find the coordinates of the stationary points on the curve y is equals to x to the power 4 minus 4x cubed plus 4x squared plus 1 and determine the nature of each of these points. Sketch the graph of the curve. This one is an interesting question because we are going to make use of sketching. So firstly, the solution. We know that we can find the first derivative of y, which is simply y prime. And y prime is 4x cubed minus 12x squared plus 8x. Then we equate this to 0 because we want to determine the stationary points if there are any stationary points. So with that, we go on to solve for x. So now, before we solve for x, we see that we've got a common term, which is 4x. So when we factor out the 4x, we are going to have inside the parenthesis x squared minus 3x plus 2, and then that being equal to 0. From there, and also making use of the quadratic factorization method that we covered in the quadratic factorization method in our videos, I encourage you to check it out once again because it's an interesting method, way easier than other methods in my view. So we are going to have that. So for x squared minus 2x minus x plus 2 is equal to 0, we group the first pair and the last pair inside the curved brackets so that we have that. Now simplifying further, we are going to have 4x times x minus 1 times x minus 2, and that being equal to 0. And of course, we move on to separate the three terms, equating them to 0, because that's how we solve for this. This would imply that 4x is equal to 0, and that x minus 1 is equal to 0, or x minus 2 is equal to 0. And solving for x, we get x is equal to 0, or x is equal to 1, or x is equal to 2. Now, to find the corresponding y values, what we do is to substitute the x values into the y equation or curve. We start with x is equal to 0, and in doing so, we are going to get the y value of 1. Then the turning point we have from this is 0, 1. We move on to substitute for x is equal to 1 so that we get our y of 2. And this gives us a turning point of 1, 2. And lastly, for x is equal to 2, we get the y value of 1, giving us the turning point 2, 1. To determine the nature of the turning points, so we know that we can get this from the second derivative. That is y prime prime of x, and that is 12x squared minus 24x plus 8. So for the first turning point 0, 1, we know that this one is a minimum. Why? Because if we substitute for x into y prime prime of x, that is to have y prime prime of 0, evaluating that, we are going to get a positive 8, which is greater than 0, implying that this is a minimum point. Then we go on to the next point, 1, 2. This one is a maximum, simply because when we substitute for x with the 1 in the y prime prime, we are going to get a minus 4, which is less than 0. This is a negative, implying that this turning point is a maximum turning point. Then for the last one, we have 2, 1, which is a minimum point simply because the y prime prime of 2 is a positive 8, which is a positive, implying that this one is a minimum turning point. Then for the sketch, we can of course plot firstly the points 0, 1, 1, 2, and 2, 1. From there, we see that these all connect. As they connect, 1, 2 is a maximum, 0, 1 is a minimum, 2, 1 is a minimum, so we would have our curve in that particular manner and order. And if you have made it thus far, congratulations to ya, and I'll leave you with the following task. A curve has equation y of x is equals to x cubed minus 6x squared minus 15x minus 7. Find the stationary points and determine their nature using the second derivative method. Post your questions so that we attend to them. This is what Numbers Simplified is for. And thank you so much for watching Numbers Simplified. And remember, God loves you.